Welcome to our second code review club. I am Josh Owens, and in a second here, I'm going to bring everyone else in. We have a new person joining us, Tyler, and then we have Evan and Sean and Steph. And then today we're going to cover, let's see, RNA transcription, and then we're going to cover space age. So hopefully you got those emails and you were able to follow along with us. Let me see if I can bring my screen up for everybody to see, and then share my screen on Zoom. Desktop 1, share. There we go. Can you guys see that?
Mm-hmm. Yes, sir.
Awesome. Okay. So, let's go to space age. And we'll kind of walk through this one. Again, like we're talking about TypeScript, and we're learning together through these exercises on exercism.io, and you can follow along if you want. All you have to do is go to, let's see, is it codereview.kickstand.work, and pop your email address in here, and then you'll get instructions on how you can join us in the future. All right, so first up is space age. The idea here is that you have given an age in seconds, calculate how old someone would be in all these various planets. So we have Mercury, Venus, Earth, Mars, basically all of them, all the planets around us. And you're calculating how old they are in orbits around the sun. Does that kind of make sense to everyone? Yeah. So if you're, is that a billion? Yeah. Billion seconds old, you're 31.69 Earth years old. So, all right, let's dive into it. Evan, you can go first.
Yeah. This is not the space age one, but...
Oh, you are correct. Let me pull up space age, RNA.
Should I turn to the RNA one, do you think?
Click on yours. Published.
Should scroll down a little bit.
There, this one. There we go.
Yeah. Alright, so let me scroll up there. So it's just a nice little function, exporting it. It's got putting in age, which is the seconds, as a it's going to be a planet, it's going to be a string, and seconds is going to be a number, so we know what planet we're looking for and how old you are. Seconds and years is just going to be a constant there, which is how many seconds are in an Earth year. We've got this nice interface here to get all the typing and Typescript right for the my planets object here, and then just have the different planets as keys with how long it is to go around the sun compared to Earth. And just doing some good old-fashioned math down here, where you just do totals of seconds that are inputted up top, how old you are in seconds, divided by seconds of the year, divided by the difference between Earth and the other planets. 10 times. Then divided by. But that's just to get it to be rounded to the correct place.
Nice.
Math.
Ah, you did 3 iterations, huh?
I think I just added TypeScript stuff.
Oh, okay. Yeah. Huh. Cool. I like it. Good work. Sean.
Yeah, so I also did the neat interface just to make sure it knows that the key is going to be the string, and then it's going to refer to a number. I did this planets object that had all of the planet names with the ages, years, whatever on it, with the numbers on it. Have the Earth seconds as the number, and scroll down. And then I used my fun little TypeScript trick where you put the plus sign and it makes it into a number. I did the formula, seconds divided by Earth seconds divided by planets. And then I did 2 fixed 2 because it only needed 2 decimal points.
Yeah, nice.
Easy peasy.
Did you have to use the plus here because you had Earth seconds is a number. Planet.
I think to fixed changes it, right?
I was just threw in the plus sign because I kept getting back a string.
Okay.
I think it's because I have my interface. I have the string as the planet, maybe. I don't know.
Yeah.
The computer didn't like it, so I had to fix it.
Makes sense, I guess. All right. And then Steph?
Yeah. I did a pretty similar thing with Sean and Evan, although I wasn't as fancy doing interface. I just kind of, within my little dictionary comparing values, I declared types in it. So I, on line 3, say that the key is a string, gonna get a number. Yeah, and then did some math stuff on 14. Pretty similar to what Sean did, I think. And yeah, I want to say actually, for me, once I put 2 fixed on there to make sure it only went to 2 decimal places, that's when it seemed to be turning into a string for me. So that's why I put the plus on the front. But I guess I can't confirm that that's really where it was coming from. It just seemed like it was for me.
It's the only thing that makes sense.
Yeah.
One sec, let me get Tyler's open here. Oops.
Oh no.
I think you gave me the link to the actual exercise there, Tyler, not to your solution. I think you have to publish it.
Oh, it's published.
Yeah, I just need the link to your published, or even your profile. I think I can find it once I get your profile.
Oh, I don't have a public profile. That might be the issue.
Uh-oh.
Once you like finish one of the problems, it'll like be like, would you like to publish this on your public profile?
Okay. Here are published solutions.
Yeah, you may have to tell it you want to publish it too.
Sorry about this.
That's all right.
I'm sending it to you right now. I think that's the one.
Yep, that worked.
Nice.
Yeah, so I had I think a very JavaScripty solution using a switch statement. But I declared my types in the function, and then the Earth years and seconds, and then just writing this function 2 years, and that's just doing the math for the conversion, and then the switch statement is passing whichever planet is getting called the age in seconds, and then I'm calling the function at the bottom of the switch statement.
Okay. Yeah, let me get down here. 2 years, age in seconds. And then you... Okay. Huh. Interesting. Yeah, I don't think I dig the switch statement so much. I definitely like the dictionary approach better, I think. Just looking at this one. This one's a little harder for me to kind of trace through just off the bat. You know what I mean?
Mm-hmm. Yeah, the like declaring the like Asian seconds at the top, and then
Yeah.
it's a little confusing.
Yeah.
Truthfully, like I did this a couple weeks ago, and looking at it now, I'm just like, oh, what am I doing in here?
Yeah. That happens. We all come back to code and we're like, what were we thinking when we wrote this
Yeah.
code?
Yeah.
Yeah, especially math.
Yeah.
Ones like this, I feel like. I don't know.
All
Well,
right.
let's like-
So I guess go try to find your RNA transcription, Tyler, while we move on. And so
Did you do one of these jobs?
I did not actually get a chance to do these.
Oh.
Yeah, I will next time. All right, so we will start with, I will say, like, this is probably, I almost skipped us doing this one because everyone here, like, has done this in order to get hired at Kickstand. So I feel like you've all seen, like, the really good solutions because you've done it, and then we go review other people's stuff afterwards. So, but yeah, we'll start with Steph.
Okay. Yeah, this is not how I did it in my interview, but how I should have done it. Again, using a dictionary, declaring the types on line 3, and just basically, you know, if you insert G, it's going to match it with C, or C with G. And likewise. And then below that, I am returning, let's see. So yeah, I did this a couple weeks ago too, though, so I am happy to remember all that I did there. But all right, I did add one extra thing that you didn't need to. I just moved it all to uppercase to make sure you wouldn't get an error if there was case sensitivity. And then, yeah, I'm splitting it into an array so that I can map through that array. And then this was different than actually, I think, in the interview, the throwing an error. So you have to check to make sure it's in that dictionary. And if it's not, it'll show up as undefined and it'll throw the invalid input DNA error. But then if it is, it matches it up, returns the value that it corresponds with, and in the end I join it all together.
Yeah, that makes sense. Yeah, and I will say, like, depending on what language you're using or you're working with, like, there are slight variations or differences in the exercise itself. So, yeah. I'm guessing they have a test that actually checks that you throw that error. Is that what they have in this one? Okay.
Mm-hmm.
I think it's the last one. That was actually the part that took me the longest too. I feel like writing that, like, just throw command in TypeScript or JavaScript seems like kind of a rare way of doing it for me.
I don't know if it's rare.
I think it's more back-endy.
Yeah, okay. It definitely. I guess I should have started here too. Like, just so you know what the exercise is, like, given a DNA strand, you need to return its RNA complement. So, DNA and RNA strands are sequences of nucleotides. So DNA has A, C, G, and T, whereas RNA has A, C, G, U, and those can translate back and forth. So this is the mapping GCTA goes to CGAU, right? And so our goal here, I wish there was a way to pull up the test suite here. That would be kind of nice to see.
Can you do the open in editor box?
Oh yeah.
That's where I always did.
Yeah, that might work.
And then I think the tests are on the right side too. Yeah.
Oh. Is this mine? This is mine. I did this a while ago. Goodness. Okay. Well, I guess I can walk through mine. I probably wrote this like 2 years ago. Yeah, so I just created a nucleotide mapping. It's got an input nucleotide, which is a string, and then we return a string. So we're just creating this dictionary up here. And then we've got the toRNA function, which takes a string, returns a string. Got the DNA matchers. These are the DNA pieces we want to catch, and so then I call test to see if we have DNA. If we don't have DNA, then we'll throw the error. And then I split and map the RNA array. We do, as we move through here, the nucleotide is a string, and then we just pass that to do the lookup in the dictionary up here, and then join it and return it. And yes, here are the tests. So you can see, like in this, you get you get past C, you have to return G to C, yada yada, until you get down here to this one. This is where you really have to think about like the array looping factor here. And then these are the tests for like invalid inputs, essentially. I don't love my solution looking back on it.
Definitely seems like a lot.
Huh?
It seems like a lot.
Yeah. Very, very verbose. Alright, close that one. Alright. Sean, you want to walk us through yours?
Yeah, so this is my solution. First I made an RNA string with a let so it could be changed. Just made it into string, made the interface so it knew it was taking a string, returning a string. Made my little DNA object. And then I just did the for loop, so it was running through each character of the string that was fed into it. If the character was in that object, it just concatenated the RNA string let that I had made. Otherwise, it threw that crazy error. The error was also the part that took me the longest time, just because we're not used to throwing errors.
Yeah.
Like this. So that's the one that tripped me up the most. And then at the end, it just returns that RNA string.
Yeah, I definitely think throwing an error has a place in code, right? And I think Evan's right. Like we use it a lot on the one client project that we're working on, where we're like a lot of times we're like catching the errors because we have to deal with like different libraries actually throwing the errors. But I think they can be valid and they are good. I don't know, honestly, I don't think I would write this way. I would just like, I guess if you're getting invalid input, you do want to maybe throw the error, because you don't want to, like, the other option is we could just drop the ones that don't match, but I don't like that would be an incomplete DNA sequence. So yeah, I don't know, you probably do want to throw an error here, right? Otherwise you end up with like a deformed dinosaur in Jurassic Park.
If you're actually sequencing DNA, you would want an error.
Yeah. The for of is interesting too, but I do think going this route versus like doing a map pushed you to like use a secondary variable like RNA string here, right? Whereas if you did the map, it builds that array for you. You just have to return the DNA lookup that you get, and then at the end just join it all back together. But I guess the concat avoids the join. So
yeah. It felt like the array felt like an extra step if we were just working with strings.
Yeah.
At least in my opinion, you know.
Yeah, because this made you not do a split essentially, because like for of just means you're getting the split part kind of free. That's interesting. Nice.
Cool.
Ooh, Evans looks different.
I went a different route. I went readability. It's very like clear what's happening for me. And shortness. Yeah, so I just take the RNA in, which is a string, you split it, split strand, then you map through the split strand, and then do just like the if, basically just like your guys' dictionary, but just a couple of if statements. Because I feel like I already did the dictionary in the last one, and I wanted something slightly different on this. And then throw the error if none of those are true, and just return the RNA and join it.
You know what's funny is like looking at this solution. This is like I would be torn. I might hire you. I might not. Like I could tell you, because like you do the split in the map, and so it's like, oh good, like he understands how to like iterate and do that kind of thing. But then you reach for the if statements, and it's like, yeah, dictionary. I still think a dictionary is better here than this particular block. But you're not wrong. This is very readable.
Yeah, I was gonna say the same thing.
Yeah. Yeah, interesting.
I mean, it's also less code than the dictionary one, I think. Maybe not. Seems
Yeah,
like
you're at 11 lines of code. I think I closed some of them.
Yeah.
At space age. Yeah, I'd have to reopen them. Let's see. We'll look at Tyler's. Oh, he's got a lot of. You pasted some stuff up here.
So -9.
Yeah. Yeah, yours is long.
Yeah.
Dive into it.
Yeah, so I went with like the JavaScript map object. This is how I did it in the interview as well, just because it gives you the get method. I unfortunately didn't TypeScriptify my sequence map. But yeah, then going, just declaring the response, and then looping over the DNA map that I split, and then throwing an error if the gene doesn't exist in the map, and then pushing to the response, and then returning the join response.
Has and get, are those just the same method?
Has is just returning a Boolean, and then get is returning the
actual value. Okay.
Yeah.
Oh, that's fun. I haven't used has with the map yet, so that's kind of fun.
Yeah, I'm not sure why I did undefined again. I did this a few weeks ago.
Yeah, that's what I was gonna ask. I wonder if you had to have this here because you weren't maybe throwing early on, and you were maybe getting an error, right? Because here you're just saying that res is either gonna be string or undefined, right? And then you're gonna return an array of string or undefined. Yeah, and then you join the return value. Yeah, I think this could probably be cleaned up just a little bit.
Yeah.
Interesting.
Yeah, maybe because I'm declaring it at the beginning with the let, and it's undefined then?
Yeah. I'm not as familiar with what an empty array would come back as, right? Because you're saying the elements in the array could potentially be undefined.
Yeah.
Interesting. Can we... If I click here... Community solutions, there we go. So one of the things that I love about this site in particular is that you can go, like, once you submit, you can go look at the community solutions and kind of pull them up and see how other people are doing it. This one is actually one of my more favorite ways to solve this. Do they do that this way? No, they don't. This isn't it. Thought maybe it was. There's a reduce, but man, look at that. It just looks like a dense block of like, what the hell's happening? Oh, here you go. Yeah, this one I think does it. Okay, so here, this is taking in a DNA string. So we're going to return a string. It tests to make sure that, you know, we have only DNA in here. If we don't, we're going to throw that error, right? So we're taking care of that first, or those last three test conditions. And then call DNA.replace, which takes a regex, and there's a little known piece to replace that most people don't realize. So you pass it the regex matcher, right? So we're saying we want to match GCTA. We're going to do it globally in the whole string. And then you can pass it a function. And so every time it finds a match, it will kick off this function. And this one's fascinating because they're using charat to return CGAU charat GCTA, right? So they're literally treating this like an array, and then doing a match and returning the index, so it'll return the actual letter of the match. Like, so if it were G, it should return C, C should return G, A, T, A, U. Yeah, you guys get it. But this one's a little crazy. Like I don't think I would have come up with this. This one, again, this is like, from a readability standpoint, I don't think I would go for this particular method, but it's kind of fun to see it and realize that you could do something like that.
Mm-hmm.
But I don't know that I'd want that in the code long term.
I just tend to not like regex.
I love regex.
Hate regex.
What's
Regex is
this
awesome.
one do? Yeah, this one's just kind of doing the map similar to what a lot of everyone did. Why? Oh, that's in. No? Why? Yeah. I'm a little confused as to why they're using that operator there. Oh, okay. That's essentially creating their array. That's essentially replacing the split by using the rest operator. Huh. That's interesting. I haven't tried that before. See? Go through this, you learn something new. Yeah, that one's pretty similar. Let's go look at Baba Hops. Nuc map. Yeah, see, like, just, it's only a couple lines. Just type it out and let us know what it is. It's nucleotides. Alright, so it takes a DNA string, gonna return a string. Again, interesting. Use the rest operator here to create that array without using split. Then calls reduce. Are you guys familiar with reduce? Yeah, a little bit. So it's the idea that you have this output and you have this letter, and the output is returned right here, and so each time you cycle through that reduce, you're gonna get that output, and it's gonna build that output as it goes through. So reduce is a way for us to, you can see they're returning the output of the reduce directly, and they're just essentially building without having to join. So in the first iteration, let's say you get G, it'll drop into this loop and return C, and then if there were a second letter, C would come in as that output, and you can see they're just like building it right here. Does that kind of make sense to everyone? And then I guess they account for if they come across. See, this one's actually a little less efficient. because you'll get like halfway through an invalid string before you throw an invalid DNA input.
Mm.
Yeah, interesting. All right. Let's see, what exercises come next? How do you see them in order? All exercises?
If
Available, maybe? Oh no.
Might be on the overview at the top.
I think it's
Yeah.
D&D character and
Okay.
pentagram.
Yeah, like I think that's the order.
Yeah.
Yeah, we skipped resistor color, space age, D&D character, and pentagram. Okay, so we'll do these next time. I haven't done D&D character, so this will be fun.
Nice.
For a game, each player starts by generating a character they can play with. The character has, among other things, 6 abilities: strength, dexterity, constitution, intelligence, wisdom, and charisma. These 6 abilities have scores that are determined randomly. Do this by rolling 4 6-sided dice. Record the sum of the 3 largest dice. You do this 6 times, once for each ability. You have an initial hit points of 10 plus your constitution. Write a random character generator that follows the rules above. Ooh, this one's gonna be fun.
Ah.
All right. There's a programming language called Troll. That's fascinating. All right. So yeah, we'll definitely do D&D character, and then we'll do pentagram, and I'll put that out to the mailing list as well. So again, if you aren't joined, just go to codereview.kickstand.work. You can sign up there, and we'll let you know about the next one. And then for pentagram, you're basically just looking. A pentagram is just saying that a sentence contains every letter in the alphabet, right? So the quick brown fox jumps over the lazy dog has every letter in the alphabet. So I think you're going to just be given a series of strings, and you have to determine if it's a pentagram or not, and return true or false, I believe. All right. Well, thanks everybody for joining, and I guess everybody can wave before I turn the Zoom off. Yes. All right. So we will see everybody in the next episode. We'll probably do it 2 weeks from today, which would be the 23rd. Is that cool with everybody? Yeah? All right. So like 2 days before Christmas, we will have some fun doing reviewing these programming challenges. And in the email I send out, I will make sure to include a link to where, if you want for us to look at your code review and talk through it, have someone read it and give a critique on it, then we're happy to do that. You'll just submit to Airtable with your links, and we'll be able to pull them up and share those as well. Thanks for tuning in, and if you do have any questions, my email is just josh@kickstand.work. Always happy to chat and help people out. See ya.